So just to recap quickly. So last time what we saw is spatial library introduction, right? And how it works, couple of functions, attributes, their different methods, correct? And we, in the first class, we did everything manually, right? So same thing, almost same thing, or similar thing we saw, like how we can make use of library and do the similar operation and more advanced operation without writing your own function and all, correct? So a couple of more things are pending, which we'll continue today, okay? So I think we were done till here, right? Print index of each token, was it done? Or maybe, I think it was done till here. Frequency of words, correct? So we had frequency of each word that we had printed, right? So after that we have something called print each word count using dictionary comprehension. That also we did, right? Correct. So can you guys do that once again? See, few things might be repeated, but this is good for you so that you can do it online and practice more. So let me check the last variable. It was object. Yeah, these things we had already seen, correct? So this NLP object was created, and from that object we can take each word. But these words are what type? Class type, correct? These are class objects. So from that object you can convert to text type. So though it looks same, but if you would like to do some string related method and operation, right, you cannot do. So you have to convert to text type. Fine. So we have to do this using dictionary. How to do that? Let's do that one by one. So I'll just break it so that you can see the full output. So dictionary comprehension, what we have is what is my original data? So we had created objects here, text, right? TXT. Okay, so in TXT only we will search everything. And TXT is what? It's a raw text. Okay. We can directly do that. So first word will be your, the key will be your word, and count of that word from where? In the TXT, right? TXT is your string, and I want to count WD, correct? For WD in WD dot text. WD, we are counting what? Text. Yeah. So it's very straightforward. Exactly same thing we got here also, right? Using for TH, correct? So guys, it is up to you which one you would like to do. Okay. So for me, it is pretty simple. No need to go with ORTH and get the number of that particular string, then go back to database, filter, convert it to text, right? So that is little tedious, but I'm just showing you the option. We have both the options. Okay, this is pretty much and very much straightforward. Is it clear to everyone how to print it using dictionary comprehension? I think this is repetition, but I hope you guys can revise and get it done. Right. Online guys, is it fine?
Yes, fine. Okay.
So I want to hear from others also. Okay, I think only apart from Bhavani, no one is speaking. Don't just listen and see. Say something, even if it is not clear, I can repeat. Okay, I want to make sure it is clear to everyone. Okay, guys. So anyway, this is frequency count of each word from the given text. Now let's see, in case there are some situations where you would like to know what index was that word present in the text or the file, correct? So we have one attribute called index in the NLP object. Okay, so we'll see how to print that. So There are multiple ways. Either you can directly print, or you create object, and from that object get each word. And for each word, we have so many attributes because it is again from NLP object, right? So that object you can keep printing using dictionary comprehension or list comprehension, correct? So you can create a dictionary of words and their corresponding index as their value, or you can create a list of word and their index. Right? So let's see how to do that. So again, I'll take for word in object. So you see, right, everywhere I'm just using object, and inside what we are using, their attributes. Right? So it's very simple. Okay, so let me create dictionary, and so word dot text will be my key, and from WD I can get their index. So that is index. Okay, index is not there. What is it? ID. IDX, right? Yeah, IDX. So I think every library is using different shortcuts. Some using ID, some using IDX, index. So you can print in one line. See here, so just I'll take one word, commercial. So for commercial word, what is the index of this word in the whole text? It is showing zeros. Zero means exactly at the beginning. Correct? You can see here. Correct? And it will ignore all the spaces. Similarly, next word is writer. So for writer, it is 1. Correct? Where I'm getting writer as 1. Okay? So like that, you can get all the indexes. And this is just, wait, this is. Okay, so it will count from here, right? 0, 1, 2, 3, 4 up to 10. And sorry, 9, and then 10 will be your space then, correct? Like that. Like the way we count the character of each.
So each character it is assuming as index.
Yes.
Each word
Correct.
it will ignore spaces.
No, it will count the space also. It will not ignore. But while listing, it will not list the space. Only it will consider the words. Okay, because a string, how do you get the each character? Using index, right? So let's say THIS. So T will be your 0th. That is your first character. HIS. S is your last character. After that, if you have space will be your next character. So that is also having index. Okay, so but NLP will automatically filter all the space. It will just consider the word and their corresponding index. Fine. So any doubt, guys, how to get the indexes? No? Okay, next we'll see what are other various attributes.
Pankaj, you explain the line 23.
Line 23 is there.
20. I
Okay.
like.
So here, up to here, this is clear, right? For WD, that is nothing but a word variable, or it could be object from this object. That is your NLP, correct? And but since WD is object, so instead of printing directly object, we can get the text of that object using WD.text. So this is my key, and since we are using dictionary comprehension, so value should also be there. So value I want their index, WD.IDX.
IDX means?
IDX is the wait. Okay, I'll write. So IDX is index of the given word. Fine.
Okay.
That's what it will print. So maybe there could be some scenario where you would like to see what is my position of that word in the whole text or the file, right? So this is the best way to visualize it. Okay.
So index value will be corresponding to the first word character of that word.
Yes. So basically, it will take each word and left to right it will scan. So the moment it's basically internally it will be searching all the regular expression. Okay. And regular expression as so right, it returns the span like from 0 to where it is matching. Correct. So that span is nothing but getting converted as your index. Okay. So now we'll see print various attributes of NLP object. What are different attributes? So we have already seen a couple of them, like IDX is one of them, then count is one of them, correct? So now we'll see is alpha. So if you would like to see whether that particular word or whatever data we are getting, is it alpha or not, alphabets or not, correct? You can directly check. If it is not, you can ignore it. So in the first class I talked, right, while doing the pre-processing, you would like to consider only the dictionary word, no numerical value. So this is the best flag to capture this instead of writing the regularized display pattern, correct? That is the power of CC. So let's do that. So how to do?
So that is alpha is a function or
Attribute. So which will have true or false. If it is not a word, let's say it is not included in the dictionary word. Okay? Let's say 1, 2, 3, 4. This is not a dictionary word, right? It is a number. Okay? Commercial is one English word. Okay? So automatically it will have true or false detail. Okay, so let's see. So again, maybe I will print all the details in the form of tuple. Okay, so for WD in OBJ print, so I have to use tuple so that every parameter I can print. Okay, so first is WD dot text. Fine. Now this WD dot text. Let's see whether it is for each word we'll check few things. First is like whether it is alphabet or not. Okay, so again WD dot is alpha. See here. So these alphabets true. Similarly, this is not alphabet. It's false. This is not alphabet. Correct. So like that you can easily filter which is, so okay, let me complete this, then I'll tell how to create list of words, list of numbers only. Okay. So a list of any set of word or any set of what to say character which is not an alphabet. Correct. So next is shape. So as I mentioned, shape is nothing but whatever set of character like uppercase, lowercase you have, right? It will automatically return their shape also. Okay, this is also very important. Let's say you would like to filter those words which is having all set of capital case. Okay, so let's see how to check the shape. So WD dot shape. Shape is another. See here. So what it is doing, it is just printing the number. So as I mentioned, each word is having own or unique number in the database. Right? So instead of not to print the number, you just add one underscore. So underscore will have their corresponding string. Okay, you see here. Okay. So you can see the first word is your capital. So this will be capital X. Rest will be small. Okay, that is the shape of my word. Correct. Similarly, this one, all are small. So all are small. Correct. That's how you print it. Yeah. So shape is nothing but one attribute. Okay. So we have shape without underscore, with underscore. Okay. So first see what is the shape. So shape is nothing but it will have uppercase and lowercase of X, which will tell like okay which character is my which character is having uppercase letter, which character is having lowercase letter. So that shape only will be represented by X. That's all.
So the commercial is having like
Capital C.
Capital C, but it is having around 9 characters, 9, 10 characters.
So it will not show all the 9 characters because after that, if let's say this one is capital, so if shape is getting changed, right, that shape will get captured.
Then how is it taking how many X's to print there?
No, this is not to check how many characters are there, because for that we have different methods. Length of that we can check. Correct. This will just show okay it is beginning from the capital letter and rest are small.
So suppose R is capital there in commercial.
Yeah, if let's make that. Maybe I have to change it, but maybe we will take one small example. Okay. So here I'll create another OBJ. 2 I'll create, and here let's take okay commercial writers. Fine. And this is getting created using NLP. And let's see what it does. And this will be OBJ2. Now see. Correct? So this is the way to get it. Since it is continuation, right? So why to put all the things? It is just like highlighting, okay, this is my shape of the word.
If you see the last X is small.
Which one?
Small.
Yeah, because this is L, right? This is small. This
Small.
capital L will be this. Correct? Now you can see. Right?
That's
Yeah. Yeah, this later gets confused with one and small L. Both look same. But there will be little tilt here with this flag. I hope it is clear to everyone. Okay, what is the shape? Okay, now we have a couple of more. So let's say we have PUS. So PUS I think I have already shown is part of speech. So part of speech, like, okay, if I say some sentence, right, each token or each word in the sentence, what is the meaning of it? Basically, what is that? What is the property of that particular word, right? Is it noun, verb, subject, adverb, adjective? Correct? So every type of that word will be shown. So for that also, again, same thing is stored as a number. Correct? So if you don't want to print number, you have to add the underscore. Okay? So let's see. So now this is the shape. I'll take the original, okay? OBJ. Fine. And we have something called wd.pus. POS is nothing but part of speech. So every part of every what is it type of the word is already stored with some number, right? But I don't understand what is 84. So to see corresponding word for that, you can just type this. So these are adjective, this noun, verb. I don't know what is that. So I'll tell you how to check the meaning of this also. Adjective, noun again is part. Correct?
If I give only POS some letter values.
That's what I'm telling. These words are also stored in the database with their corresponding number. I told right how it is maintained in the spacing. The moment you load this model, right, English model, you load it, right? This has all the details. Almost every possible word of the dictionary is stored with their number and corresponding word as a string. Okay, their property with corresponding number and corresponding words. Everything is stored. It's a very big model. That's why it took time and we have to download from the internet. Okay, but nothing to worry about the number because we mostly don't need. So whenever you get a number, just add underscore. So it will convert to the string. This is one good thing about it. Okay, what else we have? Tag. Let's see what the tag is. WD dot. Again, tag is having some special meaning. Okay, so we'll see what is JJ, what is NNS. Okay. So those who are really working on grammatical thing, probably this will make more sense. Fine.
What is the tag mean?
Okay, so tag will also have similar to like whatever we did this, right? It will have little more meaning. I'll show that how it works. So probably once I get the meaning of JJ, probably I'll be able to tell what exactly it does. So this clear, guys? Okay.
It is adjective.
Yeah, ADJ is adjective. We are speaking English nowadays, but we almost forgot all the basic grammatical detail. Correct? So nothing to worry, but Spacey will help you. If you would like to see the meaning and what it does, we can get the information. So there are so many other tags also or other attributes which I'll explain. It's not working and I'm feeling very hot here. So any doubt guys so far? Okay. So did I mention punctuation? Okay, it is not there, but let's add one more here. Is punct. So is punct is nothing but is it a punctuation or not? Dot, colon, semicolon, correct? So this will be also very helpful. Why? Because instead of writing the pattern to remove dot, double dot, right? You can directly use this. Right? So we'll see how to do. So do we have any punctuation here? Maybe dot and other things will be there, right? So if I add now, this will be gone. So you can see here, it is already listed here. Yeah. Correct? And tag is nothing but maybe tag is like from which family it belongs to. Correct? That is the reason it is giving the dot. Correct?
So here it will add true or false.
Correct. And this will be punct. So it belongs to punctuation. That's why it is punct added. Correct. Now let's see whether it is punct or not. So earlier it was printed what? False. Now I'll check whether this belongs to punctuation family or not. So what it will be added? True here. Correct. So let's see. WD dot is punct. See. So all the words, they are dictionary word, they are not punctuation. That's why it is false. Now let's take a look at comma. Correct. Dot. These are punctuations. Correct. So mostly all is special character where like full stop and another thing we are right. Those will be considered as punctuation. Is it clear, guys? Now can you create? Let's do one exercise, small exercise. Okay. So I want you guys to filter all the stop word directly from the given word, a given sentence, using list comprehension. Okay, this is exercise for you. We did a lot of filter even and odd, right? Okay, so filter stop words. There are so many non-stop words, right? But we'll try to get all the stop words. Filter stop words from the given text using list comprehension. So this will recap all the things. Good for you guys. Online guys, this question is clear?
The same text will give.
Yeah, you can use any text. If you have compiled everything, then you can use that.
Using basic function.
Yeah, so basically I want you guys to start using these attributes. So now I introduced right, those attributes. Using that you can create. So you know manual method. You can easily do that, right? But let's start using attributes. So in one line only you can do. If you can do above, then this also you can do. Done? Using attribute, right? What about others? Tell me what problems you are facing. What about online guys? Say yes, no.
Yeah, Pankaj, doing.
Okay. Second one also, right?
Second one.
Just one small change will be there.
No, like most of us.
Correct.
Not
Just give not equal to.
this is not right.
So equal to true. So this is the way you filter, correct? Correct. And if you give not equal to true, then it will be correct.
Exclude.
Yeah. So this is the way, another way to do that. So guys, I would like to hear from you where you got stuck, because it's very simple problem. First, create the NLP object and iterate over each word using for loop and check the attribute. What is the error? For what in object 2 you created, right? Why did you comment it? List of objects, okay. For okay, dictionary will have colon, not comma. Okay, so we have given it is not working. Is stop, okay. WT object 2. Okay, object 2 will be you have to create using NLP function. Okay, that is like so many small issues. That's why while hearing right, everything you'll understand. So practice is required because you'll make a small mistake, right? You just wrote object 2. It is not object. That is a variable. So you have to create using NLP function, correct? Right? So let's see here, guys. So object I have already created. So we'll just check the word. So using dictionary functions. So for WD. So now you guys know, right, how powerful is dictionary comprehension. In one line we get everything. And that was the reason I introduced in the first or I think second class. Correct? And now you see the actual uses. So for word in OBJ, what I want? WD dot. So we have to check the condition also, right? So if WD dot is stop equal to true, then only print a WD. Correct? What's the thing? It's clear? Okay, so that is the first problem, and second problem is not stop. Or you can give equal to false. Anything is fine. If it is false means it is not stop word, it is actual dictionary word. These are the words. I hope it is clear. On guys, is it clear?
Yes, Pankaj.
Okay. Okay, so now we'll see new concept.
So is there any other option if I want to extract that English version? Is there any other versions?
Other function to get the stop word.
Other function as well as other English version we are importing English version that
So see, we have so many other options. So you load the dictionary of stop word, and again using list comprehension and condition, you check whether that word is part of that dictionary word. I think we have already seen that in the first class. How to when I introduced stop words, we checked the NLP part 1. Correct? So we loaded all the stop words, you remember? From NLP, from Spacey, from scikit-learn.
yeah.
So using membership operator also you can check. That is another way. But Spacey is having everything inbuilt. Just use the tag or use the attribute. And using true false, you can just filter it. Correct?
Yeah.
Okay. So let's see the new concept, guys. So new concept is stemming. So stemming is very important concept in our natural language processing. So what it does basically, let's say you are having so many sentences, right? Or maybe in one sentence, so many words are there. There are some words which belongs to same root word, but they are having different forms. First form, second form, third form. Just check ready. Yeah. So what I was telling in the sentence, one word. I mean, so many words are there, and their root word belongs to same word. So what do you mean by root word? So let's say go. So if you take any English word, let's say you take any verb, go. So it has three form, right? First, second, go, went, gone. Correct? So if you are reading one sentence and doing a lot of analysis in that, you might find these three words together, correct? In different contexts. So what is happening? As I mentioned, right? Once you apply machine learning, or once you create what to say, matrix of each word, correct? because ultimately machine learning understand what zeros and ones and some number. It will not understand the string. So every word has to be converted to the number. Okay. So go is also there, went is also there, gone is also there, and each word will be considered as one feature. So if you keep adding these kind of words without removing them, it will add what? Extra dimension. Okay, and your matrix will keep growing. You have to remove that so that you can reduce the dimension. Correct. So go, went, gone is nothing but same. Go only. So why do you have 3 dimensions? We can have 1 dimension only. Correct. So to reduce the dimension, this is stemming and lemmatization is another thing. I'll just talk about this also. It's very important. But there is one fundamental problem with stemming. So what happened? Let's say we have. Maybe I should take one example. Let's say we talk about walk, walked, walks, and walking. Correct. So whenever you apply stemming, right, what happens? It will always chop the last one word, one character or 2 characters. So while chopping, it doesn't maintain the dictionary root word while chopping. So what I mean to say, let's say in the walked, or let's talk about the gone, Gone. It might chop only the last character, that is E. So after chopping, what it will become? Gon. That is not belonging to any dictionary word. Correct? So this problem, or this is known as fundamental problem of the stemming. That is the reason Spacey doesn't support stemming. Okay, it supports only lemmatization. So lemmatization is, in short, I would say, it is advanced form of stemming. So while chopping the character, it will maintain the root word of the dictionary. Okay, of that word. So that this kind of problem will not come with gone, right? We saw GON. This is not a word. But unnecessary, you are adding one dimension which is not carrying any information. Because that is not belonging to dictionary word. With the stemming, correct?
As in jobs of until we do.
Yes. So it will try to maintain a dictionary root word. That is the fundamental, the difference between stemming and lemmatization. Okay? It does the same thing, but it will try to maintain root word of that dictionary. Okay, so I'll show one example. And since we are not going to see this in the Spacey, and we are not going to use also, I would not suggest you also to use. But you should know, because if you go for interview, right, NLP related, this will definitely come in the interview question, though you are not using. But it's a fundamental concept of natural language processing, right? Stemming lemmatization. What is that? What do you mean? What is the fundamental problem with the stemming? Okay, so let me show that problem and you will understand why to use, why not to use. Okay, to show this, we have to use these 2 functions from the NLP game. Okay, so let's import that. I think I have already done it. No, right? So we'll do it here. So there are 2 different kind of stemming in the NLTK. One is Porter stemmer. These are the person who developed it, and one is snowball stemmer. So you can read more theory like in what algorithm they use. But let's talk about it. We should not worry about the theory and all right now, okay? Because this will have a lot of research and a lot of calculation and all. Right? How it does. हाँ वही तो यार ब्रेक ले लें तब कर
ठीक है ब्रेक के बाद ब्रेक जल्दी दे देना चाहिए
okay fine. So maybe after this we'll take the break and we'll shift it in. For you I think fan is there, but for me it is too much problem.
Outside is called.
Correct. You want to shift now itself? Shall we? Okay. So as I mentioned, for stemming, online guys, this very basic definition is clear, right? For stemming and lemmatization.
Yeah.
Okay. So to show the stemming, we will be using an NLP library. For that, we will use 2 different kind of stemmer: Porter stemmer and snowball stemmer. Okay. So they do exactly same job, but only thing this Porter stemmer is little advanced than snowball, but problem persists on both. Okay. So let's see how to do that. So from first we import snowball. Okay, from let me import separately, though it is there in the same library. Photo HTML, right? Run it, and now we have to create the instance. These are the classes of the HTML. Okay, so we have to create the HTML object. So maybe I'll just use snowball HTML equal to snowball, and this function takes one argument called language. Okay, another thing you can ignore stop word and all. So we'll go with the default. And what language we are using? Just write English. And we'll create porter HTML using, and luckily this doesn't take any argument. Some mode is there, but that is already set. Okay? Just create it. After running, let me create some sample object, some list of word, that is LOW, and here I will create, let's say give, then I'll take given, I'll take gave, and gives. Do you have any other thing? Giving. Okay. Now apply the HTML. So if I apply snowball HTML, what it takes? It will just take list of words. Not callable. Okay, then stem.
So it is case sensitive. So first.
Yes. Correct. So did I execute? English HTML object is not callable. Why? Snowball HTML. Then what we have is stem. Stem, and this will take the word. So stem English word and return. Okay, got it. So instead of creating list of word, right, I'll just create one sentence. Okay, sentence, and this sentence I'll have, because we should apply over the sentence, right? Not the list of word, because list of word will be coming from the sentence, correct? Like word token or sentence token. So let's say for time being, I'm just writing one example. And this sentence is having some different kind of thing should be there, but I'm just writing all the words together. Give, given, gave, given, and giving, then gives, and giving. Okay? And now we'll apply the word. For WD in sent. WD. But will it work? There will be one difference. So instead of getting word, I am getting character because this is a string. So what I have to do? Create the NLP object. Correct? NLP object of this string. And from NLP, what we can do? WD.text. Correct? So WD.text. Right, we got each word. Now we will pass this text to HTML. Because that is what we want, right? We want to check each word and what is their root word. So I'll use print and print the word dot text, and in that text I'll pass it to HTML. So snowball HTML dot stem, and what is my word? Yes. See. So give is fine, give is also fine, given is also okay. No, but it's not okay. What it has given? I was expecting give here. Because given is what? Third form of the give, right? And here, giving. So for giving, I am getting give. That's fine. Gives, I am also getting give. Giving is also fine. But for the given, it is not able to do it properly, right? because some challenges are there with this stemmer. It will not do fully, and if you do fully, there will be some chopping. So let's take one example also. One more example. Maybe I'll take
So after
I have taken one sentence.
yes. Sorry.
I have written my own sentence. And
But content we have to search different words, right? So let's take one small what to say list of directly those words plays and played. I would like to show the problem here. Play, plays, played, play, and what else? See here, this is what I was talking. E is gone, right? But this is not a dictionary word. Okay? So if you just take some random word, just take some random word and create all the forms and apply this stemming, see what happens. There will be some word where they have chopped some character and it is not all belonging to dictionary word. So that problem will be existing. Okay, so this is the one problem. Now I'll take same thing using Porter stemmer also. Okay, so let's see. So I just have to use this, and instead of applying snowball, I'll just use Porter stemmer. This might return the same output, but that's fine. See. So though it is advanced version of snowball, but it is not maintaining the root word of the dictionary. Correct? This is the challenge. That's why Spacey is not having the stemming function. Okay, and that is the reason we have to use what? Just to see the example of this, we have to use NLP. This is the problem. Okay. To overcome from this, what they have used, advanced version of stemming, that is called lemmatization. And it does the same thing, only the difference is it will maintain the root word of that dictionary. Clear? So if interview it will ask, you guys can answer it, right? Clearly. Okay. Anand guys, is it clear?
Yeah, Pankaj. But where this stemming is used, because it can be
No.
updated, na?
No, it might be available with updated version in NLTK that we don't know when it will be, but in Spacey it will be very simple to get the root word. Okay, so we'll see that, how to do that. So Spacey, as I mentioned, definition of lemmatization, it is exactly same as stemmer, but it will maintain the root word of the dictionary. Okay. So for word.text, what is my word.lemma? So lemma is your attribute here. So what it does, what happened in bracket? Yeah. So similarly, lemma is also attribute, and every word is having one lemmatized word in the dictionary, so which is also having some number. Okay. So print the number. Not to print the number, you just have to use underscore. Now see. Okay, I would suggest play with different word. Okay, I'm not getting right now some other word which can show significant difference.
Here also the same words.
No, but you see, root word is maintained here. So playable, right? This kind of like it is a kind of adjective, so that will maintain. Okay, but here you see, for these root words, this play is the root word, right? So now you see, from this 1, 2, 3, 4, 4 dimensions are there. And this will be reduced to 1 dimension because only one word is there. Is it correct, guys? Okay, you guys understood?
why playable was not converted to play?
Because this could be related with some different adjective, different kind of combination might give the different meaning altogether. That is the reason. You have to maybe go with like very deep of the English grammar. Correct. Okay.
So Pankaj, giving is also showing giving.
Come again.
Giving is also means showing giving in lemmatization.
Is it? Let me show. Let me take this also. And
Viewable.
yeah, let me see. Okay. Send equal to this, because there could be some other rules also for giving, and you will understand the meaning of this because once we use this one, right? Bigrams, trigrams, n-grams. So whole meaning will get changed if you just take one graph. So I hope you guys remember in the first class I told, let's say,
So two things it is giving here. So giving one giving and for giving give. So it is adding both.
Root word is giving.
oh wait, no, there is two giving.
One time
One time it removed.
Oh, that is something strange.
also taking in the context of the sentence meaning.
Okay, yeah, because sentence is there, right?
Sentence meaning
That's
also.
correct.
Here you give.
Maybe if I go, went, gone.
The root word is maintained.
Okay. Yeah, because sentence we are writing, right? So based on the context and the meaning, it will try to mean. That's what limitation
Either it
is.
is converting or leaving to base word.
Correct. There are some algorithm which
It's like what is coming in
Take a
what
look.
context.
correct, based on the context only it will be converted.
So basic difference in stemming and limitation is like limitation is leaving the whole word if it is not convertible.
Correct.
Otherwise stemming is
Stemming will chop.
Always stop.
It always chop.
Even though if it is not a root word.
Yes.
limitation will leave the word if it is not.
I would suggest to read more about the limitation. How internally it works.
Stemming doesn't make any sense.
That's why stemming is not there. And I'm just showing you difference because it might be as in the interview. Because if you are applying NLP, then definitely these things you would have come across, right? So in the pre-processing, we always use limitation. Okay. So let me store this back. You guys can play with this later and. Okay, so maybe we'll take 10 minutes break. And meanwhile, we'll move to other class also. Where my patience level is going down now. Yeah. Online guys, is it clear?
Yeah.
Yeah, please remember the difference and play with different words also, okay? And I would say just Google it, limitation. You will get more theory of how it try to maintain the dictionary root word, okay? And that will be really helpful. And remember, this will be used for reducing the dimension. Where exactly use reduce the dimension and maintain the root word, right? So whenever you have sentence, right, and you would like to visualize the sentence in a tree form, how to do? Okay, so using display, it is very easy to do that. If you remember, I had imported few detail here related to display. Correct, display C. Display C, so display C. Correct. So this is used for data visualization, text data visualization. Okay, so let's see how to do that. So here I'll write one small. Let's create one sentence here. Fine. So once you create the NLP object, right, what you can do, you can just visualize it in the tree form. Okay. So tree form will have all the details like what is the word, what is their tag, what is their POS, and what is their dependency in the previous word or next word. Okay. So everything will be visualized using the arrow. So let's see. So we have display C, then we have render function in this. Okay. In the render, you just give what object you would like to display. So we have obj3. Okay. See here, it's very easy to do that. If you see here, this is line 1 and used for display C purpose, correct? So those who know like core grammar of the English, they can understand what are those words. So this is, so is, it is depending on this, right? So it will show this arrow is line 1. So after is we have like subject, verb, object, right? Those kind of concept is there. So whatever is dependency, that will show line end, right? I don't know where exactly we can use it, but this is just to quickly visualize the dependency and all other words. And whatever attribute we have used, right? Tag, part of speech tagging, everything is used here. You see here. These are the tag and attributes. That is nothing but part of speech tagging. Correct? It's clear how to display. And those who are not able to display, right, we have an option called Jupyter that we make it true in case it is not getting displayed. But by default it will come back. Right? So this is what I was talking. If you want to see what is the meaning of n subject, attribute, CC, cons, what is that, right? So we have direct function to do that. So this is what is next. So sp.explain.
That is conjunction.
Yeah. So let's say I would like to see the full form of this. Correct? You can just type it. You tell. This is nominal subject. Correct? Similarly, you would like to see prep.
Preposition.
Yeah. So whichever is not here, right? Let me show P object compound. Okay, let's see that. ADP is also there, right? What is ADP? ADP. Add position. I really don't know what is that. Don't ask me. Very poor in grammar. PREP. Preposition modifier. Correct? So things are there. If you really don't understand, just use sp.explain, give the meaning, give the word. That is spacey object, right? We created on the top. Import spacey. You forgot? Clear to everyone?
Yeah.
Okay. So those who are going to work on properly, the Grammarly application I explained, right? So I think they will be using this heavily. Okay. So based on dependency and all, they will check what's supposed to be the word, why that mistake, before that preposition to be used or not, right? So things will be getting checked using all this trivial.
The Pankaj, is it showing means is it showing a wrong word like Grammarly shows wrong word like correct one?
Correct. So there is some other thing also running, machine learning algorithm. Correct? Because every word is existing in the dictionary. Only thing is we just load it to the computer. If you're typing something else, it will keep checking in the background whether it is really existing or not. If it is not existing, automatically it gets highlighted, right? Because some processing is happening in the background. That is like live processing. Correct? So that's about displacey. And next we'll see named entity recognition. This is also very important. What is named entity? I think I had explained in one class. Last class, I think I talked about it. So let's say you have a big sentence, okay? And in that sentence, you would like to find out all the named entity. So what is that named entity? Let's say some company name is there. What is that company? It's organization. Okay? So automatically it will tag this belongs to organization. Correct? Let's say some $1 is mentioned. What is a $1? It's money, right? Automatically it will tag that it is a money. So you can get the details and you can visualize it. That visualization is very powerful. I'll show how to do that.
To find out the difference between small IT and capital IT.
So that's what. So once you do lower, right? So capital IT will become it. And if you are removing stop word, it will be removed. Okay? So in that case, you have to add the IT in the stop word. Okay? Sorry, not the stop word. After removing, it should get added. Yes, appended. So that IT can be recognized as organization. Okay, so let's see. So maybe I will take some random text here from wiki. Okay, so global talk. Let's talk about global talk in wiki because that will have a lot of entity. Okay, you take any random page. Okay, I'm just whatever is coming in the mind. I'm just taking, and that's how you should also start thinking. Okay. Let me just copy paste this. Fine. So in this, I'll take obj4 equal to NLP and this one. Okay. Let me just visualize and I'll show what is the meaning of the display C dot render. Then we have what to display, obj4, obj4, and here we have something called style, and style will be used for ents, that is entities. Okay, and as I mentioned, Jupyter will make it true in case it is not getting displayed. Unknown display is by okay. Is what I was talking. Just random text. Go to wiki, copy paste, and create the object. Where it went. You can see. I don't know this name, but this is GP. Some geographical maybe. Okay. So let's see what is the GP first. So sp dot explain what GP. That is countries, cities, and states. Some GP name. Okay. So it could be country name, state name, or city name. Now next one is Korean. So that is NORP. What is NORP? You can always get the meaning right. So nationalities or religious or political groups. So they have grouped those kind of names. Okay, that is what is entity tagging. Not this is a person name, so that's why you got person. Club 7, this organization. Okay, this could be company name. Global talk show. So work of art. Okay, they will keep updating because you never know, right? Some new thing come and it is not there, so you might not be able to see that. Okay, so always keep updating the library, you will have it. So for date, you will always see date, and this is the quantity. Automatically it will filter, see? Correct? This used for display purpose. But how to filter it? How to filter in the text format? That also I'll show. Just create the object and display C dot render. Actually, this is this one. This I'll show after this.
Style.
Style is entity. So what you would like to, this has couple of different style. So by default, it will show dependency, the one which we saw in the display C, right? These are the dependency. Okay. And if you would like to mention all the other thing, then you can put that. You can have some other like minify, Jupyter options, different. You can read little more. Okay. How it is used. Minify HTML markup. Maybe you can reduce the font size and all. So display C you have to import here on the top. We already did it. From display C import display C. Okay. Just try again. So online guys, is this clear?
Yes.
Okay.
So, Pankaj, I have a question. Like in the South Korea, it is showing the GP, right? So
Correct.
where we can see okay, what are the GPs? Okay, okay,
That's what I told, right?
okay,
SP dot
okay,
explain.
yeah. So that.
Because even I don't remember all the meaning, so just use SP dot explain and just type that word. It will tell you.
Okay.
All the countries, cities, and states are linked together with the GP name. Okay.
Okay. So one more question: is there anything like because it is highlighting the South Korea as the GP, so we
Correct.
can find that how many GPs are there in the text?
Correct. That is what I'm going to show. That will be okay.
Okay. Okay.
So how to do that? That we'll see. The display part is clear, right? Okay. Now we'll see how to do. So where is that object? I could have created it here. Okay. And now for word in obj4. So what we can do instead of displaying, we can print word.text, and we have one more attribute called wd.end. Ends or any R name HT recognition. NT is also not there. Is it working for you guys? Or there will be directly one attribute. So object dot ends. Okay, this is the problem. GP and all those are called label. So once you create that object, from that you get the word and just print the label. So again number. Okay. So now how to find GP? Total GP or total. Let's say I'm just interested in person number, person name. So how many such persons are existing in total that given text? So you can convert into what? List comprehension, right?
What tuple?
Yeah. Or you can use list comprehension.
Okay.
For word in object entities, use WD dot, or maybe I'll use if WD dot label equal to what? Person, and create WD. These are the person names. You can quickly filter. You can see GBs of data, you can filter all the person names. And what is the length? Total number of persons? Oh, correct? I hope it is clear.
Yeah, Pankaj.
Yeah, so process is just create from the object you take this attribute ends. Like we talk like each stop, correct? POS, part of speech. Similarly, we have end stack attribute which will give the word, and from that word you can take the label, because again word is what? It's a class, right?
Getting some value, invalid object path to displacing.
Where exactly?
After object,
Here only?
the
For display.
Yes.
So obj4 you just created,
Yes.
okay? After that you give style as ENT.
Correct.
Should work. Give me. I did not work.
Object 4 you have.
So again you have not given NLP, right? Same mistake you did. Let's try that.
So Pankaj, I have a question regarding the line number 66. What is the mean of the Jupiter here, right?
Yeah. So this one you are talking, right?
Yeah, yeah.
Yeah. So sometimes what happened? Maybe it has to be updated now, because by default it gets displayed. If you would like to display this in Jupyter Notebook, it has to be made as true.
Okay.
Because even if you don't make true, it is by default getting displayed. So that's fine.
Okay.
In case you face the problem, make it true.
Okay.
Okay. Is it fine, guys? Okay.
Yeah.
So I think next three things we have already seen, right? Remove stop words, punctuation. We already saw. Create a list of words, sentence. After removing stop word, then make sentence. Right? So anyway, this we will see in the next case study. Okay, we have to do that exercise. And sentence, word, and tokenization. I think we have already done that. Why it is existing at the last. Yeah. Someone else. This one?
Yeah.
So guys, any doubts so far?
No, no Pankaj from my side.
Okay. Yes.
No, you use level, no? Level.
Label. That is used here. So this label underscore is nothing but this GP, NO, RP, person. Okay, because these are also stored in the database with their number and corresponding string. Fine. Okay, anything you would like to explain me again? Want me to explain? Or all clear?
Pankaj, that display C function where it shows graphically, I mean, it's
Correct.
like so it can it be useful for a whole paragraph or only for one line?
No, this is you can pass a bunch of file. Maybe I will. Okay, maybe let's show that. Okay, a good question. So yeah, I should take some big text. I'll show like how to, let's say the whole text we just copy pasted and stored as a string, right? Now I'll store the other text file. Read the text file and just convert this to display C. Okay, so let's see how to do. So again, now I'll take Obama's speech. It will have a lot of detail, right? Take this one. Continuous text is not there. I think this is big text, right? Let's take this. Okay, now what I will do, I'll just create one text file and save it. So assume that you are having one text file, right, and save it. Okay, and save it as Obama. Fine. Close it. Now let's read it. Save or not. So fh again file handle will be used here. Open Obama speech.text, correct? And we are going to read the whole text. So again, text will be what? String, correct? So instead of doing okay, this is fine. Enter. Now NLP object. Let's say I create object 5 equal to NLP. And how to get the whole text? fs dot read. Fine. Now you got this object. And just use it. So display C dot render. What to display? obj5 and style entities. Jupyter anyway by default is coming. You can see. So just click here, you'll see all the details. I think in a couple of web pages you have already seen this thing, right? This is coming from display C or display C, correct? See, the Congressional Hispanic Caucus Institute, ORG. See, the big word also recognized ORG. What's this? You are getting bored?
Yes.
Okay. So is it clear, guys? Okay, and remember that this is not an image, this is the complete text, but automatically some HTML format will be created and automatically highlighting will happen. Okay.
Pankaj, I want to see from that text. I want to see all the verbs, nouns, like graphically what you shown to us. That
So what do you want to see?
that noun, verb, preposition. What you shown before that, like graphically what?
Oh, this one.
This.
So that just call that, but this will be very big.
Yeah.
This will be very big. Okay. Before displaying this kind of tree, just remember what you are plotting.
For particular sentence is fine.
For particular sentence, it makes sense actually. For graph also, okay, let's do that. Anyway, the only thing is it may hang. I don't know it will hang or not. But so obj5, right? It may take some time. Yeah, it has come. Okay. But you can see it will be very much overlapping with a lot of details. And if you see the scroll bar, you're able to see here.
Yeah.
This is a scroll bar. It's very big. Full
Very
sentence has come. But even you will be lost what you are looking, correct? So it will not make sense. Sentence by sentence you can do that. And you can save this. This is a figure, I think you can save it also later.
Proper sentence and
Yeah.
in a loop like this.
Yeah, correct.
But why it is not showing sentence wise?
No, it has taken the sentence wise, paragraph wise, but only thing is it is showing in the horizontal thing. That's why you're not able to see that. If you just read it, right, like S17, which would
Okay.
have, you are able to see, right, these things.
Yeah.
This is sentence only. So it is just like stretched, like it has made as a flat, no new line. Everything
Yeah.
is one line. So that's why it will not make any sense, but that's fine if you want it to display like that. Okay?
Yeah.
I'll just comment it so that you can run it later. Okay, guys, any more doubt? No?
Pankaj, I have a question.
Yeah.
Well, suppose a name entity, whatever you was displaying here,
Mm-hmm.
suppose so there is some organization which is not in the list.
Which
That
one?
is no, I'm saying suppose there is organization or there is a person.
Correct.
This
Yeah,
is
that's
not in the dictionary.
correct.
Then how it will handle this kind of things?
Yeah, so I think you have some option to update the named entity also. Let's say my company is not listed. Okay, how to add that? That is also organization, correct? So that there is some option I have read somewhere. I don't remember the option, but you can just add it. Like how we updated the it and IT, correct? Same way you can
Correct, yes.
yeah, same way you can append to the existing entities and get it listed. You get it highlighted. Maybe I'll check that option. What is the direct function? And I'll reply.
Okay.
Okay, but we do have option to do that.
Okay.
And here
So
also
and one more question. Yeah.
here also you might find some word which is supposed to be like date. Anyway, date will always be there, but organization might not be there. Okay. So like America, okay, they would have mentioned directly as a GP or something. Countries, correct? I don't know why it is not existing because they might have considered the whole world. Rebuild America. Correct?
Yeah.
So if you would like to include this also, you can add it and just get it highlighted as GP. Okay, I'll check that option.
Okay. Okay. So I have one more question. Like we know, right? Whenever we do like tightening data set, after you cleaned it, so we have already the list of like things where we need to fit to like ML. So here in this case, like in NLP, so what is the like endpoint? What is the endpoint of our all cleaning, whatever you are doing? What is the end thing we got after cleaning, after doing all these things?
Okay, end thing you will be getting the text. It will be sentence. So let me just take one example. Okay. So let's say where is the text? Okay, maybe I'll just talk about this. Okay. So assume that you have this text up to only this line. Okay. Once you do pre-processing, what you will be getting, you will be getting the same sentence. But only thing is, date will not be there, these comma will not be there, and all the stop words will be gone. You will be getting the sentence. How to make the sentence that I'll show with the help of case study. Okay? Because you will be doing a lot of pre-processing, you will be converting sentence to the list. But from at the end, you have to get the sentence right. So you have to later you have to join it. Then you will get the final sentence after removing this.
So the whole paragraph will be one sentence, or
No,
each
yeah. So
sentence will be.
let's say this is one sentence. You can consider this as a one paragraph. So you will be getting one paragraph. Okay, if it's just a sentence, you will be getting sentence. So it is up to you. What is your requirement? You are processing the sentence, you are processing the paragraph or what? But whenever you talk about the machine learning process, you have to convert to sentence token. That's what we did, right? And later you work with the word token, and later you combine and make the sentence again. That's what we are going to see next.
Okay. So what is the like we recognizing name entity? And what is the use of that? Like why we are doing it, and even the rendering also. What is the use of like we know limitation? Like we are finding stop words and all this we are doing, right? But what is the name entity? What is the purpose of like we are recognizing this name entity?
It is just used for as I mentioned, right? One is like you can just highlight the person name or the any kind of entities. Okay. Another one is like one person asked here in the class like how to find total number of person in the whole text. Correct.
Okay.
So you can just filter using this technique, using for loop. So if you would like to see how many such countries are mentioned, just filter GP. How many such persons are there? Just filter person only. Correct. How many work of art was explained or talked about it in the whole speech? You can filter it. So some kind of statistics, if you would like to build from the text, right, then this will be helpful.
Okay, so we are not filtering the like person or name of the organization. We
No,
are
no.
not filtering out. Okay.
In display C, for visualization, we are not filtering. But later, if you would like to make separate count for each entities, right, you have to filter it based on the need. That's what we did here, right? So I would like to see the person. So I filter it. Whatever entities are belonging to person, just give me those words. So I got total to 4. And you see the list of name. Correct?
Okay. Okay.
Yeah. So it is all up to use case. What use case you are using.
Okay. What are you doing the rendering? What is the use of that?
So render means yeah. So wherever you are displaying, right, it will render in that format. So this is HTML, right? So that render will take care. Okay, this is just for visualization purpose. You can read it here actually. This one line. Render display C visualization. Like basically creating graph in case of map.dev or creating the chart here. Correct? And in this case of rendering, you write the whole text, but along that you add some HTML tag with color coding and entities. If you see the HTML code, right, I think I don't know whether you will be able to do in the MacBook or not, but you can add the whole HTML. You can check the whole HTML code. You'll see extra thing will be added in this particular area. That is the color and highlighting the entities. Okay, that is what is rendering. It will do some processing there in the background and display for you. Okay. Anything else?
No, nothing.
Okay, guys. So next is our case study. That's all about Spacey. Okay. These are the attribute functions we are addressing, and we have a couple of more things. Okay. Before proceeding here, we have one more thing. It's not easy to get to case study directly. I don't know today we'll be able to do or not. We have one more part pending. Where is third part? Yeah. I think we missed few. Meeting got closed. Guys, you are able to see the screen? No, right?
No.
Yeah, now somehow it got closed.
Yeah.
Yeah. So where is the download section? Couple of more things are pending, right? Yeah. So sentence, word, token, yeah, these things are pending. I think we'll be able to complete this only today. So let's finish. These are not much. So get all the reading file is done, right? So maybe I can just mention it here. Okay, guys. So let's see another steps in Spacey. Another good thing or powerful thing which I saw in Spacey was adding some pipelining. So if you remember what is pipelining, I told like the moment you create the object, right? What it does some pre-processing internally, correct? If you want to see stop word, if you want to see part of speech, you want to see entity, it would have already done all the processing and make it available for you, right? In the form of attribute. But what if you would like to do some other processing also? Before creating an NLP object, right? You want your operation also to get performed, correct? So that is something called custom pipelining. You can add your own pipelining. Okay, so as I mentioned earlier, I think 2 or 3 functions are already existing. The moment you create the NLP object, you can add some own another one function, two function, three function, whatever you want. Okay, so let's see how to do that. So first we'll see. So I think OBJ we are using so far, right? Okay, we'll take this only. So we have something called obj dot pipe. If you just type pipe, right? Not. Yeah. From NLP object, the one which we created. So what are the pipe labels? Pipe names. So if you just run it, we have tagger, parser, and NER. That is named entity recognition. And parser, it is doing parsing. So after parsing only, it is able to filter what is my stop word, what is my punctuation, right? That's why we are able to get it, right? And this is a tagger to tag it, whether it is adjective, preposition, or verb, subject, whatever, correct? So these are things are already happening. They have already inbuilt functions in the pipelines. These three functions which I was talking in the previous class, this is already existing. Okay, to get the pipe name, this is what you do. And we have something else also like NLP dot pipe. This is some method. I'll tell you how it works. Before that, pipe labels. Okay, these are different labels, tagger and cardinal date. That is why you saw here, right? Correct? In the entity, cardinal date, event, FSC, GP. These things are already existing if you like to analyze it further. Now we have something called pipeline. Okay. So now what are those pipeline basically? We have tagger. So tagger is nothing but another kind of function, which is tagger function. Parser is another function. So it is just showing you the detail like where exactly it is existing, some memory location. But there is not much use, but I'm just showing you because these things you can get. Fine guys? Clear to everyone? So the moment you create an NLP object using specie, these are the things which is getting called for the text. One by one. First tagger, then parser, then NER. Now if I tell you I would like to add one more function here, it means you are adding your own custom pipeline. Okay, so that we'll see how to do. That is the next step. So before that, let's say I would like to create what are different pipelines existing other than preloaded. We have one more thing called NLP.factories. See, tokenizer, tensorizer, tagger, morpholizer, parser, NER, which we have already seen. There are so many others all existing. On the fly, you can add if you want, based on the need. I've not seen all the details, but I'll tell you important thing is how to add your own pipeline. That is very important. If you don't want to write, one of them you can pick, like merge entities, how to merge them. Okay, merge subtokens, entity ruler. You have to read little more detail what each pipelining does. Okay, so we have some more existing that you can add it. But that is not our goal here. Our goal is you can create your own function and later you can add in the pipeline. That is very important. Okay, so let's see how to do that. So before adding, I would want to show how to remove the existing one. Why that removing is required? Because let's say you have large set of text and for that text named entity is not your goal to perform. So what will happen? Internally it will perform, right, one by one. Tagger, parser, then NER. So NER will also take some time. Correct? If you have large set of data, let's say GBs of data, unnecessary or wasting time to do NER also, which is not you would like to see. Correct? So in that case, it makes sense to disable the existing pipeline. Okay? To save some time. That is the only purpose. So how to disable it? We have something called NLP.disable pipes. So disable pipes means multiple pipes also you can disable. So let's say if I would like to disable NER. Okay. So now NER is disabled. That's why you see here. How to check it is disabled or not? Again, I'll check. Get pipe names. See here, it is giving only tagger and parser. Correct? Then you pass your object to NLP object. Pass your text to NLP. So it will not do any NER. You will save some time. Some amount of time can be saved. Is it clear, guys?
Yeah.
Okay, so let's say you disable it and you are trying to do entity recognition. It will not work because NER is not existing. This pipeline has been removed. So later, if you want, you can enable it once again. We have something called restore. So basically, this is creating object, right? I could have saved that object because on the object only you can apply restore function. So maybe I'll just create this once again. Okay. So before that, I'll check it is enabled or not. Okay, enabled factories. And whenever you disable, right, make sure that you create one object. So NER OBJ, and you can print it. It's very important, guys. Okay, please remember that. Now you get the pipe name Tiger. I would like to restore that NER because I want to do some processing, right? How to restore? Go to NER object, and we have something called restore. Okay, check whether it is restored or not. Check again. NER is back. Now you can do name entity recognition. So this is what removing or disabling or enabling the existing one. Now we'll see how to add the custom pipeline. This part is clear, guys? To everyone? Okay. This is very important once you operate over large text. Otherwise, fine, you can ignore it. Okay, this is just to save the time. Custom pipeline. Let's see that quickly. It is very small one. So before, let's say I have decided to make all the text whatever I'm passing, right? Everything should be made as uppercase. Let's say this is my goal. So far we have been operating over lowercase, right? After doing the processing, I want to make everything as uppercase. How will you make this uppercase? Let's write one function. Yeah. So let's say my function name is appraiser, okay? Which will do the uppercase conversion, right? And this needs text, correct? I'll pass the text. Now remember, these things are already happening, right? Tagger, parser, and NER. It is happening over what? NLP object, correct? That object must be called here. And where, because we are going to add this appraiser also, right? So where it will be added? You can add either at the beginning or at the end. That flexibility is there. I'll show how to do that. So appraiser, I want a text. So my text is coming from where? From NER object, right? Because first it has gone to tagger, then next it has gone to parser. After NER, it will go to appraiser. And what is going to appraiser? NLP object only, right? So from text, I'll get the whole text. Okay, maybe I'll give some other name, otherwise you get confused. So let's say sentence. Okay, so from sentence, get the whole text. Because this sentence will be coming after NER. That will be your object, NLP object. So from sentence, get the whole text and do what? Whole text will be what? String. And return it. Right? So you can do this operation and store in a variable, or I can directly do that return. This is also fine. Get the text and make it everything as uppercase. Is it clear to everyone? Okay. So this is my function. If I would like to test it quickly, let's say I create some object here. So PHP object equal to NLP. I'll pass some text. Okay. So this is test line for my function. Okay. This is my NLP object. Now so the moment you create NLP, what would have happened? It would have already gone to tagger, parser, and NER. Correct? Now I would like to see whether it is working or not. So before doing that, what I will do, I'll just add it. So this is created. Now add it. So NLP dot add pipe. So in the add pipe, we have one function component. What is my component? Now this is appraiser component. Okay. So give the name of the callable function. This could be any function. You can write your lambda function also. Correct? Only thing, it has to return something because it has to pass right later. Now appraiser, we have some more option called name. What name you would like to give? If you don't give any name, this will be taken as appraiser only. Okay, next is before. So where you would like to add, before or after? Correct? So if you add before, what happens? Before NER, it will be added. Because in the sequence, we have tagger first, parser, then NER, right? So I will not touch it, let it be after. Or maybe if you don't add, it will be, yes, by default, it will be after. So first and last is also there. And by default, it will be last. It would have mentioned somewhere. Not last. Yeah, default is last. Okay, so let's go with the last because that is our custom pipeline, right? So now I'll add it. So to check whether it is added or not, what I have to do? See, now my custom pipelining is added. The moment you create the NLP object, right? What will happen? It will return it, right? So yeah, it will return. Now to check whether it is returning or not, what I'll do? I'll pass the object, okay? So appraiser dot PHP. And I will get this print. String object has no attribute of text, okay. So, oh, why I'm creating NLP? Because that is also fine. Sentence.txt.upper. No, this is fine because upper we can do only once you create as a string type. Okay, let me just check quickly. I'll print also, okay. So add pipe. Okay, this is already added. I have to remove it first. If it is existing, you cannot add it. So NLP dot, let's say remove. Remove is another keyword. I can remove it. So I can remove this appraiser. Yeah, name is removed. Now add. Now pipe names. Now, yeah, now it is adding, right? So what has happened? It went to an NLP object. It has got the text from whatever user has passed, right? Now it would have done all the things. It would have gone to tagger.
Return is not working.
No, it is working actually. It will work because okay, return is basically required if you are passing this to some other thing. Then only appraiser will pass, right, to other things. Okay, this is just to show the example. Okay, how it works. Now it would have done the parser. Then it has gone to the NER also. Now later it will go to appraiser. So appraiser, the moment it gets the NLP object that is test, it will do what? Uppercase. That's all you do. Correct? So that's how you add the new text. This you can remove it. Is it clear, guys, to everyone? This is very important, and because I will be using this to the case study by not adding the pipe, but later you can add because you will be creating some custom functions also. Because during pre-processing you do a lot of steps, right? But every step, if you keep calling separately, it doesn't make any sense. Pass the whole bunch of text to your function and let it go step by step. Okay? Is it clear to everyone?
Yeah, Pankaj.
Okay.
Yeah.
It's very important, guys. Okay, please make some practice here. Fine. Now let me show chunking. What is chunking? I'll talk. So before that, I'll take some text. First one only I'll take. Yeah. So chunking means whenever you get any sentence or set of paragraphs, right, set of sentences, what it will do, it will just find out the word which is depending on one word, another word. Okay. So let's say I'm telling I'm going to market. So going to market is one chunk. Correct? Let's say he is going to school. Okay. So school will be one word. He is going to is another word, right? So this kind of combination it can automatically do. And from that particular chunking, you can create what is the root word of that chunk. Like going to market. What is the root? Market. Correct? So like that, it can do this kind of chunking. Okay, we'll see how to do that. It's very important. So I'll create the object. It is already there. Object. So for word in OBJ. So OBJ object, as I mentioned, it has gone to the parser, right? It will have already done all the filtering. So we have something called chunk. chunking or chunk. Is it getting listed in your, no? Let me see. Print WD. I forgot the name, chunking or chunk. Okay, I'll search it. So chunking, rule based. If you keep using frequently, right, you will remember that. Let me just get the tag first for the chunk. Sense. Noun chunks. Yeah, this is the word I was looking. We have something called noun chunks. Yeah. So from this we can get the word dot text. You see, commercial writer, it has already filtered. Correct? So I'll make the text as tuple, and from w dot we have something called root. And what is the root text of that thing? Let's see that. So commercial writer, we are talking about the writer here, right? That is your root word. Most people, we are talking about the most people, right? That will be your root word. So closely spaced text. Text is the root word. Order words. So whenever it finds, right, it will automatically find the root word also from that chunking. So sometimes this will also be important, very important. This kind of chunking, and this will again help if you would like to find only root word from the given sentence, right? Just analyze that. It will help you to reduce the dimension further.
So instead of that whole word, we can use.
Yes. Maybe based on again use case it might be required. But let's say you are analyzing the full text, right? So commercial might be another important one. So if you do chunking, commercial is gone. Only writer is there, right? So you have to use it wisely based on the use case. Okay, guys. So this is another attribute here for the object. From that word you can get all the word, and for the word you can filter text and their root text. For the root, again, we also get the text. Yeah.
If I'm not wrong, lemmatization also do the same thing, right? You will also get the root word.
Come again?
No, even lemmatization and stemming also do the same thing, right? To find the root words.
No, lemmatization is for individual words. But here it is formed like grouping of words, right? That grouping words, what is my root word? Which one we are emphasizing? We are emphasizing for the writers. Correct? Maybe you can add some more text and take a look how it is working. Then you will understand what is happening here. Okay?
Yes, Pankaj. Yes, Pankaj.
Okay. So that's about chunking. Now let's say there are some scenario where you would like to do word similarity. What is word similarity? Let's say cat and dog. They are similar? Not property wise, but category wise, if I say. Correct? Now good and what is it? Clever and wise. Similar? Only different word is there, but property of those words are similar. So how do you compute the similarity? Okay. So for that, I have not found any direct function in, or maybe I found a function in SPACY, but that was not. One way it was not very effective. Why? Because you have to load some different models. Okay. So to show it quickly, I would use the NLTK library. Okay. You can work on SPACY also. That is fine. But I think you have to load some big. Big model from the internet. With that also you can calculate the similarity. But functionality of showing the similarity is same using NLTK or that. But only thing is SPACY might be more effective. Okay. So just for taking example, I'll take the NLTK library. So we have from NLTK import wordnet. Okay, so wordnet dot, is it wordnet or secret? Okay, wordnet. Let me just find out. Oh, corpus dot wordnet. Okay. Corpus we loaded, right? Wordnet. Now wordnet dot not. So just correct. Yeah, now it has come. Okay. So you remember in the first class we loaded a lot of corpus. Okay. In that corpus we have something called wordnet. Okay. So wordnet I'll import as WN. Okay. In WN we have something called sysnet, similarity network. Okay. Syn. So basically this what it will do, whenever you give any word, right, it will find out all the synonyms very much related. Correct? So with that we have synnet, synset, basically synonym set. Okay, and we have one more function called synsets. Okay, so first I'll explain synset. What is that? It will basically provide you the set of all the similar word for given word. Okay, that is first thing. Let's say I would like to find all the synonyms of, let's say, good. Okay, so we can find out using this one. So synset of, let's say, good. See here. Okay, so good, I'll tell what is that. So it will have all the number, all the word with different sensitivity number. Okay, so and this you see good dot n is nothing but noun, and dot 01. So this is nothing but some kind of sensitivity number. Okay, and here another sensitivity, another. I don't know why exactly they have given different sensitivity, but if you see, it will make sense for other words. Let's say commodity, only one word is there. Yeah, sensitivity. It's basically a sense of that particular word. There could be some other word related to very much related to good. It is just sensitive. How much sensitivity is there for that word? Maybe what I would say, some other word I can take. You can consider the strongness of that word.
Good in first one and second one is same, so why difference?
In different context. I'll show some other examples also. Okay. So here now let's say you have A. Okay. So this is nothing but adjective also it can be taken. Correct. So these kind of PUS has been taken, part of speech.
We can say, suppose the TV is good, better or best. We can say the strongest will be the best.
Yeah, that is the strongest word I use, right? So in that particular
best will be
sense.
the strongest
Correct.
sensitive word for this.
Correct. Okay, so now this is related to adjectives. Only one adjective is there based on that, so it has taken only one word, one number. Okay. Similarly, we have full. I don't know how this full is related to good, but maybe based on different contexts, we never know. There are so many different contexts existing, right?
We can say glass full of water or half of water.
Yeah, that's a good.
We can compare.
Yeah, you see here. So S is also there, some different short word. So N is for noun, adverb, for adjective, and S, I don't know.
Estimable.
Which one?
Estimable. How is low?
Correct.
Oh, good.
Okay, so of course we have to be aware of all the context. Based on that only we can see. But nothing to worry. Here you just have to remember whenever you find a similarity, right, all you have to do is this is the format of giving the word to find a similarity. So first you have to write the word and part of a speech, whether it is noun, adjective, adverb, preposition, whatever. So those shortcuts are there. It is listed in the SPC. Okay, and some number if you give. Correct, that sense number. Then it will return the sensitivity. The first calculating, similarity. So for calculating a similarity, there is one person, Wu and Palmer. They have written some algorithm. Based on some criteria, they will return some number or percentage. It's a fraction number, 0 to 1. So 1 is the highest. If you are getting 1 means it's very highly similar. If you're, let's say, getting 90%, 0.9, so that is like 90% similar. Okay, for that you have to use synset. Synset is used to return all the synonyms. Okay, now synset we will be using for calculating the similarity. So let's say I'm using W1 of synset and synset of, let's say, one word, good, which is noun, and 0.01. Assume that. Okay, I'll take two words. First I'll show 100% similarity, and this is also W2. Okay. So whenever you create any word synset similarity, right, we have this function Wu and Palmer similarity. So you would like to compare W1 with W2. Both are same. That's why you are getting what? 1. That is nothing but 100% matching. Correct? Now let's take some other example. I'll just merge these two.
Instead of good.n.01, we can get any two different names.
Any two different names. Okay. So let's say
So water and liquid. I mean,
better. I know better is existing with noun 01, that we don't know because we have to see with the synset. Correct? So let's run it and see. Okay, it is there. So it is returning 61%. Correct? Because it is not exact word, right? So good is like maybe level of that good. It is here, but better is like very high level. So you cannot make it 100%, though they are like belonging to the same root word. Yes. So based on the context, okay? Like that you can compare what is similarity. Maybe some scenario you may have to use this also once you do the text processing. Or maybe if you would like to remove the dimension, okay, there are so many words. You did all the pre-processing, lemmatization, everything, but still there are some words which is like different word, but their meaning is like exactly same. Correct? So in that case, you will find out the similarity. Compare each word with different word. See whichever is matching. So whoever is returning highest match, I would like to drop that because they are having same meaning, right? Because word similarity will give 1%, or maybe you put the threshold. If any word which is matching with other word along with 95%, take one of the word.
This will have to reduce the matrix size.
Reduce the matrix size.
If it is some limit, again we need to do something.
Yes, in case it is required. So again, a lot of criteria will be there in case you don't maintain the, what do you say, context of that. Let's say I like the food, I don't like the food. Okay, so like is there, but you have before that do. I like also and don't like also, right? Correct. So those kind of scenario you have to take care. If you don't care about that, then go with this. Take the similarity. Okay. So let's take like and happy. I don't know whether it will be what. Like is what? Adjective, right? So I'll make this. And happy is also adjective. Oh. So let's take, I don't know, I'm just giving random, okay? Happy with part of speech and, okay, it is not there. That's why it is giving. Happy, lemmatized word is happy, right? So part of speech is not existing with N. So to see that, I can directly find out using this. Is there with A. A01 is there, right? But why it is not fitting? Maybe it is not getting anything.
They are two different words, right?
Yeah. So let's say like also we'll check, okay? So like N01 is there. It's not like that. Okay, just see. A is also there, right? With A also it is not coming.
0 2. For A 0 2.
0 2 is here. No. It is there.
Just like
Okay, let's take this. Okay, like A02 and comparable. We'll see whether it is printing or not. Okay, this is already there, and this should return some sensitivity or similarity. Okay, something is gone. I don't know why it is not working.
Maybe W.
Like and alike.
Like and alike, right? And that is what A01. No, I just keep. No, but output of this will be printed, right? Oh, how come it is coming here?
same value.
That is very strange, right? If it is returning some value, that should get printed, right? Because in same cell, we don't have to use print also. Okay, we lost other thing, but that's
In
fine.
which case it was working.
Yeah, yeah. So maybe I can just comment it.
The same value for good and better and like
Which one? Yeah, it is exactly. Now we are getting none. It is not returning anything because there is no similarity found here. That could be the reason.
like and alike.
Okay, let's take a look at dog and dog is this, right? Noun, correct? And we'll take cat. C is what we know. 85%. Correct? Yeah. So you guys can read some more things related to that, but that's how we use to find out the similarity. And this will be one crucial element for reducing the dimension. If you don't maintain the context, but you would like to just remove all the similar words. Okay?
One more thing. The scale is from 1 to 10. But how it is?
No, not 1 to 10, 0 to 1. 0 is the minimum, 1 is like 100%. Correct? So 0 to 100%, like that. Later you can just multiply. How to multiply? You can just do that, right? And so it is giving 85%. Correct? So all fine, guys? Up to here?
Pankaj, can we take an example?
Which example?
Like a sentence and try to do it?
I did not get.
No, can we take a sentence and then we can check?
You can take. Let's
yeah.
take it, okay? So let me take. You tell me one sentence. Then I'll create.
Same previous one only.
Okay, so let me take. No, give me some good one. Or maybe I should copy from Wiki again. Okay, let's take one small word. From there are few. Okay. So let's find the similarity for each word and using different word. Okay. But maybe it makes sense to do pre-processing because R is there in some other.
Africa and country we can compare.
Let's take this one. Is having some other words. I don't know how it goes, but that's fine. Let's say I create text one equal to this one. Okay. Now, so I would like to compare the similarity, correct? So how will you compare? We have to find, okay, but we don't know the number for these. For everything you have to find out. That will be tedious. It will not be easy. What we can do for word in text one, right? Text one. Okay, right now we have not created NLP because we are going with NLTK, right? Yeah. So what we'll do, we'll find out the synonyms for wd.synset or WN, right? Not WD. From WordNet, use synsets, and I want for each word, that is WD. Everything will be printed, and from this I'll take only the first one from everything, okay? And from first one I'll take the first name. So how to create? You can get the name, I guess, directly using. Yeah, you got the name. So synsets will return the list of all the synonyms, and from each synonym I'm just taking the first word because I don't care others. Okay, so at least first one you will have the actual one, right? I don't know for president how come it is giving phosphorus. It's very, yeah. Let me see if they have a stop word here. Order speech, lang, check exceptions to leave it. Okay, let's go with the default first. So I'm just giving the idea like how you can compare. Okay, so now you got the first one, and for each word you would like to compare with the other word to calculate the similarity. So what you can do? I can create the word here, list of word, correct? So let's say list of word 1 equal to, how to create?
List.
And text 1, or maybe I could have directly used, right? Split. Text 1 dot split with space, correct? Print list of word 1. Let's see what it does. Okay, now every word I'll compare. So I got 0th word name, and that to be compared with, let's say this is my W1 equal to this one. Okay, and W2 will be what? Count equal to 0. So WN, each word to be compared with every other word. So for, let's say, word in low 1, because it has to be compared, right? Low 1. So what I can do, I could have put it here. This is the first one, and for second one, yeah, and WD1. What do we got? Okay. Second one will be what? Take same thing. W2. Yeah, synset, and from low I want, right? And this has to be not from W2. This will be low 1.
WD1.
W1.
No, I have to get
WD1.
the synonyms for the previous one also, right? Because this, the moment you get the first word, it has to be compared with this, correct? So yeah, so get the low one, and from this I'll get yeah, for each word, right? How to get the word? No, this will be W1. This will be W1. Correct?
D1 of low.
No, wait. So get the another synsets of W1, that is this one. Sorry, WD1, yeah, not this one. Sorry, WD1, and again from the name we got W2, right? Now you print the, yeah, here only you print.
You have to compare.
Yeah,
Compare, right?
similarity. So this will be my which word? So first one we got WD. I'll take like this. Okay, WD dot text over what? WD1. Okay, and what is my similarity? So W1 dot Wu and Palmer. correct? Just copy paste this W2. Similarity with W2, okay, into 100%. So string object is not text. Why? Because we got WT. Okay. Yeah, because NLP is not here, right? Yeah, that is also fine. So I would have removed this also. Not required. W1 set word and zero name. Okay. So since it's
W1 with WP and WP1 is W2.
so this is just tuple and their similarity will be here. It's correct only, right? Let me just print W2. Okay, let's see what is it printing. Okay, list out of index range. Why? Because okay, this list is not required now. No, it is required. Okay, this might not be having any similarity, and that is the reason we are not getting. And we are giving 0, right? So if you are not getting anything, and you are giving 0th index, means it is out of range. That's why you are getting here. Correct in this one. Correct. So that's what I mean. You have to do a lot of pre-processing because some words you might not be getting the synonyms. Correct. So after pre-processing only, it makes sense to do that. Okay, to make it simple, what I will take dog, cat, lion, and maybe I'll make it everything small. Okay, dog, cat, lion, and let's see if this works. Okay, you're getting it right. Something. Now this will give something. So put similarity of WD first word, then somehow it is not getting any synonyms for that. Do you guys see any mistake here I have done? So see W. Oh, correct. So this is what we want for comparing. Correct. So I'll give W1. So let's say first one W1 will be what? Dog. Correct. And this will be compared with again dog. So that will be 100%. Again it will move to the cat. So dog with cat it will compare. That will be a W2. Correct. So I don't know what is missing here. WD. Let me remove other print to object. No.
Print W and you can do once.
Okay, I think the problem is here. Print W1. It is getting as a string. That is the reason. Okay, and this has to be object. So
What error it is giving this string list index of range. It is searching.
yeah, for this also I'm giving 0. Guys, I think it will take time to build this model, but that is possible because the moment you get both the name right, sorry.
We can try.
Yeah. Just try that. It will work because ultimately you have to pass this with W1 and W2 similarity. That's all. Okay, I'll also take a look what is not working. On guys, is it fine? I'll see what is the mistake here. Something is missing.
Yeah.
Okay.
Yes, Pankaj.
Yeah. So let's proceed with the next topic, that is n-gram. So n-gram also I mentioned in the first class. You want to leave? Okay, you take the water. This is the last one, then we'll close. Okay. I think case study we cannot take today. So tomorrow I think it will be 2 case studies. Anyway, we have to directly jump to the case study, right? And I had to explain one in machine learning algorithm also. Then only you can. That will take maybe half an hour. First half an hour will do that.
Maybe we can add one more class.
Yeah. We'll see if it is not getting completed. We'll add one more. But this will take 5 minutes. Okay, this n-gram. So before using n-gram, let him come. Then I'll explain. So I think we already talked. If you watched the first or second video, right? So as I mentioned, let's say I like food. I don't like food. Correct. So if you take each word, right, what happens? I will be one word, like will be one word, don't will be another word, which will get removed using stop word. I will also get removed, right? And you have like and food, correct? So whole context is getting changed, right? I mentioned I don't like food, but you are getting like food, right? So that's where n-gram will come into picture. So n-gram means combining multiple words together. So let's say I have something called I like. I assume that stop word is not removed. Okay. Now I mention I don't like food. So once you do the processing, right, what happened? It will make one dimension for I, another dimension for like, another dimension for food. Okay. Assume that you would have removed the stop word. So this will also become same thing as first one. Okay. So I like food. Correct. So this is, let's say, this is adding to the positive feedback, and this is adding to negative feedback. Correct. But the moment you stop word as don't, then what happens? This will also become positive. It will look like positive, right? So machine learning will get confused. It will not get confused. Basically, it has already seen like food as to be treated as positive. So this will also be treated as positive. Correct. So tackle this kind of problem, we always go with the n-gram. So n-gram means always combine the multiple grams. That is nothing but multiple words. So let's say if I give 2. So n-gram 2 means what? So let's say n-gram equal to 2. Means it will combine first 2 words, next 2 words, another 2 words. Correct? It will be like this. I like, then like food, then food. That's all. That is the last one. Correct? Let's say I have used 1, 2. So it will take all 1 gram, that is all I like food, separate word. Okay. If I give 2, it will make 2 grouping also. 2 word, first 2 words. The next last one is remaining as 1, so it will leave. 1 means you are giving the range. I want n-gram as 1, n-gram as 2 also. No, in case I want to include both, I'll tell you the exact meaning. So n-gram you can mention like this. Let's say I mention 2 by 2. Okay. So minimum 2 and maximum 2. So it will just make 2 grouping. Okay. If I make 1, 2, so I want n-gram as 1 also, means all individual words, as I want 2 also. So as your n-gram ranges increases, right, it will keep adding more dimension. Why it will keep add? Because earlier you had only, let's say you take this sentence, you have only 3 dimensions. Now the moment you make 1, 2, what will happen? This 2 will be there, and along with that, let me just write in this way. I'll show this everything using pandas, okay? Don't worry. So this will be your I, then like. Okay, this is for n-gram as 1. Now if you take n-gram as 2, I mean 1, you want 1 as well as 2 also, correct? So 1 gram is there, all individual. After that, what will happen? I like, then like food. Correct? So how many dimensions are there? So earlier 3 were there, now you added 1 more. I like food, and food will also come. I guess it will get excluded later because individual thing is already there, right? So it might not come. correct? So as your n-gram range increases, your dimension will also get increased. Remember that. But it will add to the accuracy. Your accuracy will increase, machine learning accuracy. Okay. So mostly we go with 2 or 3 maximum, not more than that. Assume that you add 3 here. What will happen? Minimum you want 1, 2 will also be there, 3 will also be there. Whatever is falling within that range. Let's say you're adding 10. Now think of the dimension. All 1 to 10. 1 word grouping, 2 word, 3 word, 4, 5, 6.
All possibilities.
That's why millions of rows, millions of columns will be added to your dimension. Okay, but it will enhance your accuracy. And that makes sense to tackle this kind of problem. So whenever you do text processing, right, always go with at least 2 or 3 level of grouping in the n-gram. Okay, so how to do grouping? First I'll show with NLTK. Then tomorrow I'll show with machine learning also. Okay, they have direct algorithm. In algorithm also, you just enable that parameter. Rest will be taken care automatically. But if you would like to do, you would like to see it manually, how to do? Let's see. So, online guys, this concept is clear, right? What is n-gram? Okay, so from NLTK import, we have direct function. That is one good thing, which is not there in Spacy. So we have bigrams, we have trigrams, we have n-grams. Very simple one, okay? So let's say I have one sentence, sent1 equal to, so this is example of n-grams. Function, okay? Now let's convert. So we have bigram. So what it takes, it just takes the sequence. So from sequence, where you will get? This is not a sequence, this is a sentence. So what we have? NLP dot NLTK we loaded, right? What was the name of alias? I think NLTK we have not loaded. So there are multiple ways. You can get the sequence using word tokenize also. And what we can do, let's say sequence of word equal to send one dot split. I can do that, right? Split with space. That will become your sentence of words, a sequence of word, right? What happened? Oh, empty separator. You got it right? Now bigrams, what it needs? Just a sequence, that's all. So my sequence of word is coming from here. Now it is generating what? Iterator, because Python 3 and higher version, right? So what you can do, you can convert to list to visualize all the list element what it has created. See, this is example of n-grams, because it is making tuple, right? 1 1, correct?
We'll ask. Okay.
N-gram functions, correct? Now this for the bigram. Now let's see the trigram. So this n-gram. So just pass it. Now I'll make it trigram. See what happens. This is called trigrams function. See, first 3 words will take, then next 3 words, another 3 words. Correct? So bi means 2, right? So 2 2 it will make, correct? And single gram is what? Sequence of word, correct? So once you get the word right, you have converted the words. Now you have to make the sentence, right? Because sentence, that is what we have to analyze. So what you have to do later, you have to combine them, correct? So how to combine? If you would like to see that, so what I'll do, how to make sentence? How to make sentence from bigrams. I'll just show one so that you can do for trigram and n-gram also, right? So for, let's say, grams in this, correct? So I'll do print grams. You got it? Later what you can do? Since this is sequence of word, so what I have to do? Join them with the help of space. dot join, and join is taking one list of. See, this is what you have to do. So this is example of n-grams n-gram function. Now you got the sentence.
But in here, bigrams is being got from sentence itself.
Correct.
Then what is the meaning of again from bigrams to?
Okay, so this is not like exactly you will arrive to this particular step. What you do, you have to do a lot of pre-processing. You have to do word tokenization, sentence tokenization, and you will be again splitting. So split will do what? It will create list of word, right? Later you have to make the sentence, correct? Then in this case we have to do this.
So in this case, suppose you don't want any
After some pre-processing.
Yeah. After pre-processing only this n-gram will come. Okay.
But here if you take 2 words, it's right. Because it's repeating. So you need to take one from each, right?
Why one from each?
Because it's background, right? It's the same. The words keep on repeating.
Correct.
So we can skip those words which is repeating.
Which word which
Like
is in?
this is.
That's what I'm telling. This is not like something you will arrive directly to this functionality. You have to do a lot of pre-processing, right? Removing the stop words and all. Correct? That is the reason. Okay. So in case you are not removing the word, we have to leave it like this only. Because don't like food and don't like food, right? That will not make any sense if you remove. Correct. So if you remove this stop word, don't will also get removed. So let's see, you are not. Let's assume that you are not stopping the words. What will happen? You have to do a lot of other pre-processing also, right? Removing the numbers, removing the special character. After that only you will arrive to this step. We'll see that tomorrow once again. Okay, with the help of case study. Okay, so same thing you can copy paste here for making a trigram. Okay. So this will be your trigram. See. Correct? You can put proper word like I don't like food and it will make more sense. Let's say you put here I don't like food. Correct? Now see. So I don't like. Now it is the moment you see this kind of sentence, right? It will automatically add to the negative feedback. Correct? And here, if you see, the moment you would have gone to the normal word, I don't like food. The moment you would have removed the stop word, I like food, it will become. Correct? This is what is trigram. Now what you have to do? N-gram. So N-gram is just, it will ask like how many sequence you want. It takes some parameter. So if you see the sequence of this, N-gram means sequence and number. So number will be, let's say I want 4 per word. Correct? Just give 4. It's a better function. So with the help of N-gram, you can use, you can directly convert to what? Let's say I want only 1 gram. I want only bigram. I want only trigrams. See, very easy.
So the printer class how it is working.
Yeah, man, this join, it will create the sentence, right? So I have so many sentences to get printed, everything in the same cell. I have to use print. That is the reason. So n-gram, using n-gram, you can create bigram, trigram, single gram, whatever. Is it clear to everyone? Okay. So we'll see this n-gram once again in count vectorizer. That is the machine learning algorithm, which will make word to vec. That is also known as the bag of words. You might have heard. If not heard, you will hear it later.
Somewhere you're
Correct. So bag of word is what? You have set of word. Machine learning doesn't understand these words, right? So we have, what it needs is just need numbers. So every word has to be converted to the number. And that number is nothing but occurrences of those words in the document or the sentence. That we'll see tomorrow. Fine? That's all from my side, guys. Any question, let me know. Otherwise, tomorrow we'll see.
Pankaj, I have one question.
Yeah.
Suppose you have one sentence, suppose you have a paragraph, so you split it into sentences.
Correct.
And suppose I have one sentence is like 30 words in the sentences. So after removing stop words and cleaning everything done, I have now 20 words. Okay. So the purpose of the bigram is like we have to find out, we have to decide that like how many or like words we have to create the like engrams, like 2 or 3, whatever. Then we have to make a sentence.
Correct.
So that will be the like byproduct of all this cleaning, all this whatever we are doing.
Correct.
Okay.
And why these grams are required, right? Because the moment you teach machine learning algorithm, right? How my positive sentiments look like, how my negative sentiments looks like. So what will happen? It will see, okay, positive review, I like. Means wherever I find the like, I like, it will make as a positive review. But for the moment I see I don't like, and don't you have already removed, so that negative feedback will be converted to automatically positive. Correct? So better you make bigrams also. So that like will be there, I like will be there, I don't like will also be there. If you go with the trigram or bigram, correct? So the don't will go along with the like. That will add to the negative sentiment. Correct? Otherwise,
Always we are going to use engram.
yeah. So this thing is required only when you go with the review level, product review level. No, so whenever first, where exactly to be used? Whenever you go with the review level thing, right? Product review, food review, right? You always go with the engram because this is the scenario, right? Don't like and like.
You can add any number.
Yeah. But 2 and 3 max. If you add 4 or 5, that is fine. But you have to see whether my accuracy is going up or not.
Depends
Just
on the topic.
accuracy is going up with little fraction doesn't make any sense because you are adding to the time, adding more dimension, more processing time, more research here is. It doesn't make any sense. So you have to do the fine tuning.
Depends the context.
Yes, context, everything depends. Like context also, type of data, what is the goal of the data, right? Okay, guys. Thank you so much, and please practice whatever you have learned so far.